Hello guys, today I will explain the ultrasonic technique used to measure stud bolt elongation after tightening. So the purpose of this technique is to verify bolt tension by measuring the change in bolt length. When a bolt is tightened, so downline stress cause it to stretch. By measuring this elongation, we can confirm that the required bolt load has been achieved. This is especially important in critical flange assemblies, where uniform bolt tensile stress is required to prevent leakage. Here you can see in this picture, so we already assembled the stud and then we tighten the nut. So stud number 1, 2, 3 and 4. So all studs need to have a same tensile stress to prevent the necessary leakage. That's why here we require to check the elongation of the stud, and then we carry the data of elongation, and then we can calculate the tensile stress according to the formula mentioned in the ESME BCC1. That is the general requirement for the stud bolt assembly for critical flanges. Yeah. This technique is commonly applied for critical flange joints in piping system, pressure vessels, heat exchanger flange, high pressure or high temperature service. It is already aligned with bolt joints assembly practice. Describing the standard, the one I mentioned, ASME BCC1. So ASME BCC1 really recognized elongation measurement as a reliable method for verifying bolt stress in pressure boundary flange joints. And now let's talk about the principle. So the principle is very simple. Here we use the bus echo technique. It's totally striping technique, and we just only use the longitudinal ultrasonic wave to introduce inside the stud. Here you can see in this picture, so we apply the longitudinal ultrasonic wave, and then the wave reflect the boundaries and then come back to the probe, and then here we can know the length of the stud. So that here we need to compare the original length of the stud, and then here so we need to measure the length of the stud after tightening, and then we compare how much percent elongation is happened. But we have one thing need to consider: which kind of equipment you will use for this technique. Here you can see in this picture, there is the echometer. We can say that is the dedicated UD extensometer to check the extension of the bolt. That is the special machine to use for this technique only. And then here same machine but different brand, I guess that is Takuter. And here you can see the echometer, so different brand you can use, but you can also use your conventional UD floor detector. But we have a main limit, we have one limitation, that is nothing but that is resolution of your equipment. How many decimal digit can display on your equipment? That is the one limitation for us. In most cases, the elongation change is only a few millimeter. Let's say that is your start. Original length is only 100 millimeter, but after fastening, that's only change 100.0001 or 2 or something. That's why here we require sufficient resolution to record the data to be accurate. Here we need to calculate the tensile stress, right? So that we need to have a accurate data record to calculate the tensile stress. That's why at least you may require 4 decimal digit, but in most conventional ultrasonic flow detector, they can only display three decimal digit. That is the one limitation of our conventional UD floor detector. If your equipment can display four decimal digit or something, or uh, your data required to record only three decimal digit, or that is fine, you can use. That is not problem, but according to my experience, in most cases, the change only very only this final digit, or sometimes change this digit. That's why here we need to have the equipment need to have a sufficient resolution, can display at least four decimal digit, so that here you can use. Otherwise you need to use the dedicated UD extensometer. So that is the special machine to use for this technique. Okay, so let me conclude. Ultrasonic extensometer or ultrasonic flow detector can be used to measure bolt elongation, but the technique does not provide the direct measurement of the tensile stress. It's measured only in change of ultrasonic travel time, which corresponds to change in bolt length. And accurate data records depends on the proper baseline measurement, calibration, probe alignment, and instrument resolution. Understanding the physics behind the measurement is more important than simply reading the digit value. Sometimes only 2D people they go to job site and record the data is fine, but design stress calculation and decisioning is really depends on the that is the responsible of the design engineer or the mechanic who really control and install the flange. Okay, so let me finish the class here. Thank you for your attention, and then later we discuss more technique. Thank you very much.